o'clock you have to submit to the your work to the blackboard. Then I will give some grades for that. Is that okay, everyone? And so please bring your mini drafter side by side, all the tools whenever you attend the class. So first hour I'm taking the class, and second and third hour you're going to do some work online, and you can ask me your questions right away when you're online. So around yeah, you have to finish it by 8 o'clock, or today is 6, 7, 8, 9. So you have to finish it by within the class itself. It's going to be just a simple exercise. So everyone, I hope all you bought your mini drafter and the tools. Anyone did not until now have not bought your mini drafter and the tools? Anybody yet? I need you all to bring your mini drafter and other instruments right away whenever you attend the class. You remember this is a skill based class and you have to work on. Okay. So with that understanding, let's continue our discussion today. So around 6 o'clock, by the time when you come back for your break, after the prayer maybe, you have to start your exercise and you have to submit it before, I mean, exactly at 9 o'clock. Okay. Good. All right. So let's start about today's discussion, and this is about the this is a general practice for any engineers, that our main motto or the aim of our engineering is to prevent or to make sure that the user's safety is at most important for us. Uh, After the lecture, will you give? What do you mean? Yeah. After lecture, I'm going to give you an exercise, and you have to finish it within the class time. Okay. So you can ask me questions right away whenever you are doing it. So that way we can make sure that everyone work during the class. So don't go away and don't simply waste your time and my time as well. Okay. So as I mentioned earlier, the primary aim of an engineer is to ensure the safety of the end user. So whenever you design any product or any component, while handling the component should not hurt the user. So one way of ensuring the safety of the user is to avoid sharp edges. Please, I repeat, avoiding sharp edges is the primary requirement of any engineering design. Okay, you should not provide any sharp edges, because there may be women, there may be children who are going to use it and they don't know how to handle it. So if there is any sharp edge anywhere in the component or in the product itself, while this might hurt the users whenever they use it. So engineers must make sure that no corner should be left out as sharp corners. Okay, no corners, edges should be left out sharp, because these sharp edges sometimes could kill, and most of the times hurt, wounds. So what we have to do, we normally provide a radius like this shown here, such that accidents could be prevented. In case of an accident, also it will not hurt the end user. Just imagine you have a car, and when you're driving the car, when you put a sudden brake, then people will inside the car will move at a very faster velocity, or the reaction will be wild. So you have to ensure that there should be no sharp edges in front of the in front of the passenger. So that's why they provide everywhere. When you see the car, they always provide the seats and the others with cushion, and also the edges are normally with certain radius. So even though you hit, you will not be hurt by the radius. So please, we call it as fillet. And generally, it's a round fillet, not completely round, but a radius rather. Okay, so this radius, usually we have general standard radius, depends on the size. So usually 0.2 to 0.5 and maximum 1 to 1.5 radius is common in the engineering, particularly the mechanical engineering design. Here, why we provide a round or the fillet in order to prevent the end user from any accidents. So to draw the arc, we must find the location of the center of the arc. You know that because you see this is the radius. So in order to make the radius, I need to find out the center. All right. So we can do it in the software very quickly, but since we are learning manually, so you must know that you need a center, and then you have to make a circle, and this circle will meet, and part of the circle will be used as a radius. So how do you find the center of the arc? One way is to use the tri-square, the radius here, to draw an arc given radius tangent to two perpendicular lines. So these are the two perpendicular lines, and then you have to find an arc. You have to draw the arc. You remember in the first class when we are doing the freehand sketch, uh, I used to give you this making a circle, like making a by making a square, and find the center, and then you can join like this. You remember that? Same method here. Okay, that's why I said the freehand sketch is extremely important because once you are very good in freehand sketch, then everything will be a lot easier. Only thing is freehand you are doing it without any dimensions. Now you are doing it with dimension and with tools. That's the only difference. So the radius should be made as a square with radius as a side, and then of course you can find out the center easily. No freehand anymore, not at all. You should never use freehand again. Freehand sketches are only made when you have an idea. So you have to show your idea, you have to explain your idea by using freehand sketch. That's it. But now we are entering into the professional drawing, so no more freehand sketches. Never again. If at all I ask you a concept, okay, can you give me can you draw a car? Can you draw a steering? Can you draw a chair? Can you draw a small component? Then you can use your freehand sketch. But again, once you do the freehand sketch, you have to use the professional drawing to give the proper dimensions. So, unless otherwise asked, no more freehand sketches. So, never again in our class you use freehand. Never. Only tools now onwards. Here, no more freehand sketches. Okay, so remember, like I made the square with the radius, and then from the center of the arc, I use the compass and make the radius here. Arc radius R. So I make the radius here, and then from the square, by using this tri square, you can make the radius, and from the radius, you can make the radius again, like this. Okay, something like this. My drawing. So this is the starting point. This is the ending point. So to draw an arc of given radius tangent to two lines. So now you have to draw the arc with a given radius r is given, and tangent to two lines. To draw the tangent, it's very easy. This is the line. The radius r, make an arc, and then by using the tri-square parallel to this line, move and draw the tangent. Similarly, another one, draw the tangent and then join it. That's how you have to draw the tangent for if the arc radius is given, you can draw the tangent to any two lines. It's very easy. Remember that this is the line, and then from there you take the radius is given, take the compass and make arc. Then put the tri-square here, and then you can let me show it and by using the like I did last time, because this will not help you much. Give me some time. Let me take the attendance before that. Take that. Guys, don't think that you can just give the attendance and leave this place. Today, from today onwards, I am going to make you work on because I'm very disappointed with your performance last class. Really, I am. Your answers were. Then yesterday I seen 2 3 drawings and then I'm fed up and I did not even correct it. So many silly mistakes. I don't know why. Huh? Somebody used the free hand actually. You should never use free hand. You know that. I remember this. That's the same guy who is asking free hand sketch now. Please don't do again. Never again. No more free hand sketches. Okay, let me share the application screen. Okay, let me show you. Please answer your attendance today. Okay, please, everyone here, answer attendance. Anas Hatim Saad Alhamdan, present. Abdullah Majid Obaidullah Al Qurairi. Abdullah Majid Obaidullah Al Qurairi, absent. Are you present? Sleeping about this guy. Muhammad Abdul Khalik Abdullah Yahya. Abdulaziz Suleiman Obaid Sankof. Obaid Suleiman Obaid Sankof. Rayed Abdulaziz Othman Al Muzal. Osama Naif Habib Ala Al Salma. Khalid Muhammad Jabir Al Buhairi. Abdul Majid Zayed Asiri Al Zarani. Ryan Ahmad Abdullah Aziz. Ahmad Muhammad Aziz Al Najibi. Abdul Rahman Muhammad Atallah Al Ansi. Abdul Hadi Jalabi Abdul Hadi Al Kathani. Abdul Hadi Jalabi Abdul Hadi Al Kathani, absent. Hassan Jarallah Obaidullah Al Tuwaiki. Abdullah Muhammad Abdu Al Asmari. Muhammad Mansur Hamid Nadim. Suhaib Ali Hussain Saleh. Sultan Saad Hamid Al Hari. Muhammad Abdulaziz Hussain Al Mahia. Adnan Wissam Adnan Barashi. Adnan Wissam Adnan Barashi, absent. Badr Abdullah Omar Al-Lamaudi. Ziyad Abdul Salam Hamadi Al-Jadani. Asil Ali Hassan Al-Zarani. Iyad Abdulaziz Awad Al-Zarani. Faris Ali Hassan Abu Kamas. Yusuf Khani Abdullah Majid. Ahmad Salim Hassan Al-Harti. Abdulaziz Abdullah Hussain Al-Marshedi. Sultan Muhammad Abdul Monim Al-Salami. Al-Hassan Allawi Hassan Al-Safi. Abdullah Ayman Hussain Kamlu. Ali Hassan Ali Al-Shairi. Okay, thank you very much. The two absentees are Adnan Wissam Adnan Barashi, and the other one is Abdul Hadi Jalabi Abdul Hadi Al Kathani. Is he here? Put your number. You're sleeping? 240505. 240505. Why? Last time I asked two times. Huh? Are you here, or you just switch on your device and go away? Are you? Huh? Abdul Hadi, I will check your marks again. Whenever I'm taking the attendance, you are not here. Where are you? Never leave the class. Do you understand? So the only absent is Adnan Bissam, Adnan Baraji. If you miss the class, then you will make so many mistakes in your exercise, and I'm going to give you 0 mark. Otherwise, you are noted. Your number is noted. Please be careful. Whenever I'm taking the attendance, at least you should be there. I asked you two times, and you are wasting my time. You remember? This is a class, okay? Anyway, right? Guys, please pay attention, and this is for your own, because people are asking me every time, doctor, I need A plus. A plus, of course I will give you A plus, but you deserve it, right? You should deserve it. You work hard. At least you show me that you are working hard. How can you show me? Just paying attention. All right, okay. All right, so this is how we are trying to draw this radius r. Listen very carefully. So first, radius r, you make the r, and on the other edge perpendicular to this, mark again, and then draw the parallel line by using the tri-square. Then using the 45-45 tri-square, moving in this direction, you draw the parallel again to the other line. And the purpose is to make the square. And once you make the square, it's very easy for you. Take that as a center and draw the, by using a compass, the first point is the starting point here, and then you make the arc from the starting point to the ending point. Clear? Now only you have to work like this, because once you are accustomed, once you are practiced, then it's going to be very easy for you. You can use your mini drafter itself. You don't need to use the tri-square. Simply you can use the mini drafter, and you can draw it very quickly. Correct? Okay. The next one is to draw an arc of given radius tangent to two lines. So you know tangent is a line that is on the arc. So you remember, if this is an arc, the tangent is the line which passes through the what do you call it? It's a tangent. It can make like if this you draw another one, this is 90 degree. So that is the tangent. So now we are trying to draw a tangent for this line and this line. Okay. So what we should do, if you know the radius, take a point and mark the radius here, and again like this, and then use your tri-square or your mini drafter to draw the tangent here. Okay. Now you watch carefully. Radius r, and make the arc. Use your tri-square and move it parallel until it meets the tangent point. Then draw the parallel line there, and that tangent to the arc. Similarly, for the other side, take radius r and draw the arc, and by similar method, you can move it and draw the tangent by using the tri-squares as shown. Clear? Okay. So let me just repeat again for your own. There are several methods, by the way. So you can see how they draw this. Okay, I think this is a little complicated for you guys. So let's do it again. Let me see what we can do it here. Maybe for some of you this could be a little difficult. Let's see what I can do here. So how can I use it? we'll start right over again. So our idea is to draw an arc of given radius r, which is tangent to the two lines. So the tangent to the two lines means you have to make an arc for these two lines. That's it, the green color line. The radius is given already, and the initial drawing this tangential line is pretty simple. Once you know the radius, mark the point anywhere here and draw an arc, and then draw the tangent by using the tri-square the way it's shown. So draw the first tangent, and then similarly from R for the other line, and draw the tangent again, and these both tangents will meet at your point here. So this, now you see you have already drawn the tangents for these two lines from the arc. Now take this as the center, and you see the radius r. Now mark the point here, which is the move it there, and then mark this point. And now take the starting point and those are the ending point. So this as the center, and make this as the radius because this is the same radius. Remember that we are taking the same radius here, and draw the tangent here, another one here, these joints here. So make sure that this only this step is a little uh, complicated because of the fact that you have to identify the point, the starting point and the ending point here. So how we did that, again I repeat, just watch it carefully. So put your 45 tri-square parallel to this line, and then use the 30 60 tri-square on the broad end of this, and then move it all the way to draw a perpendicular line to the point given or point made. So this is a perpendicular line. So that is the TP1, the starting point 1. And similarly, by similar procedure, you have to draw another perpendicular line for from the green line to the point here by using the tri-square. So now take this as the center, this as the center, and start from here. You can mark the radius here. Okay, this is for an angular cross section or angular edge of a component. How to draw the radius. And please remember, these are automatically done in the softwares nowadays. But as an engineer, we should know how these arcs are made, even by a computer. Okay, computer is also a machine. It works on certain program, and the programs are made by certain expressions or mathematical calculations. The mathematical calculations are made by this methodology. So it's extremely important for the engineers to understand the theory behind, and it will be easier for you to later to draw it by using a software. So don't feel that why should I draw all this? Because of course you are an engineer. An engineer means the most difficult job in the world is being an engineer. An engineer job is the most difficult job, because the simple thing is just we make things for the people, and our job is to ensure the safety of the people. That's our problem. So an engineer is supposed to work very hard. An engineer is supposed to know everything. An engineer is supposed to suffer. So that's why engineers are always not very happy. Whenever you go anywhere in the world, they're very serious people. They're always worried. I never seen in my design as a designer. We are very difficult people. We are, It's our job is so tedious, and simply because that if I make a mistake, the entire company will suffer. That's the problem. If you make mistakes from the design, then everything that follows will be a problem. Okay, they purchase the materials will be wasted. They do the manufacturing will be wasted. They do the assembly, they cannot assemble it. Money loss, time loss. So the designer is always in trouble. That's why the designer's job is the most difficult job, and perhaps they are the highly paid people everywhere. In Singapore, a designer, normally a mechanical design engineer, will get $20,000 Sing dollars easily. So, please, that's why our job is a very difficult job, but of course, we need to do this. All right. So, don't feel, oh, Bear, why should I draw all this? This is how it is made. Okay. Good. All right. Now he makes an arc for an angular section. So what he did, in order to understand this, they draw a parallel line by using the what do you call it, the arc method. You take the radius arc and draw the tangent parallel to this. Similarly here, and then mark the center point, and the starting point will be a perpendicular line to this point for both lines, and then take this as the center and this as the radius and starting point to the finish point. They will make an arc. This is your exercise today, so you should be very clear about that. All clear? This is your exercise. You have to make it today. Any questions regarding this, guys? Any questions? People are asking questions. Let me see. Anybody's asking question here. Yes. How many degrees we should move the triangle? Degrees? Why you need degrees here? Huh? Can you? Yes. Repeat it one time. Repeat. Okay. Grades are very less. Don't worry. For each class, maybe two grades, not more than that. 1 hour, 1 mark. 2 hours, 2 marks. So you're not going to. I will give the radius. Of course, I will give the radius. Okay. Okay. Let me show you again. Their question. They're asking what size the lines. We will give the radius and how many grades this for this one. Yeah, I will give the angle. I'll give the radius, and then you will do that. Okay. So. All right, so let's see it again. This is easier, however. Now, the, to draw an arc of given radius tangent to two lines, okay? So, arc radius will be given. These two lines also will be given. So, first take the radius will be given. 5 mm, 10 mm radius will be given. Take a point and mark the arc. And then somebody is asking the angle. You know what you do? First use the triangle or the tri-square parallel to this line, keep it, and then draw the parallel line or the tangent by just sliding it. There is no need to use an angle for the triangle. You understand? Let me go back again. See how they did it. First they draw the radius and then put the triangle parallel to this line. Clear? And then use the other tri-square, and then we are just drawing the, last class we did this. Draw the tangent by using the adjustment method. So move this triangle all the way until it reaches the surface of the arc, and then you draw the tangent from the arc. Very similarly, from the other line, first make the arc, use the same tri-square as shown, and then slide it by using another, the 45-45 tri-square, and draw the tangent by moving it all the way to the arc, and joining the line from the radius and draw the tangent now. Both tangents meet at a point. Mark that point. And then now we are trying to draw a perpendicular line from the point to the lines each in order to mark the center, the starting point and the ending point. So again we are using the tri-square. Now we are trying to draw the perpendicular line for the point here. And you know how we are doing it by simply first keeping the parallel, the main one, and just sliding it. Okay. So now you see they are trying to draw a perpendicular line from the point to this line. Another one is very similarly and join it like this. Okay. Now take the and draw the arc radius like this. Now this radius joins these two lines, and which is by using the tangent. Any questions now? Any questions? No questions. Okay, good. So in the exam, in the exercise, I'll give the angle here. So what I do to make your life easier, what I will do, uh, I will give the lines and then I will give this angle 45 degree. So it will be easier for you. So you just take the a small point there and draw this line 45 degree, and I'll give the radius. Let's say 10 mm. Then if you take this 10 mm here, a radius, draw the line, and another radius here, the same 10 mm, draw the line here. So this will be meeting at this point. Then by using the tri-square, draw the perpendicular line from here and the perpendicular line. So this joins here. Take this as the center, this as the radius, and draw the arc. Is that clear, guys? Good. All right. Or without this angle also you can draw it. You can select your own without the angle, then you can make it, right? Okay. Any questions again? Let's see any questions from you. What they did. Any questions here? Okay. Again, clear, clear, clear. Not yet. Okay. I cannot. A lot of time I cannot entertain. So just go back and see the read it again. So you will get to know. The last thing I did not understand. The last step. What is the last step? Can someone explain him in Arabic? Can you type message him? Okay. What is his last point? This point is clear, right? First point. First point is we are drawing the arc and then draw the tangent. Right? Tangent is some point from the arc parallel to this. Then use the same method and draw the other line, move it forward, and then draw the radius. And from the arc, you draw the tangent, join it there. Now, these both points are joining at here. Now you have to start drawing the perpendicular line from, because initially this is the, what do you call it, the tangent. This is the tangent. And now you have to draw the perpendicular line from there. So how to draw the perpendicular line? This should be 90 degree. Okay, this is the line. So this is another line. So it should be 90 degree. So how can we make it? So again, we are using the tri-square, parallel, and just move it. Now you see, this is 90 degree. Can you see that? And so that will hit here. So that is the starting point. Now we mark it, the first point. Similarly here, and draw the perpendicular line from there, mark it here. This is the second point. Now take this as the center. You take your campus, take this as the center, this as the radius. Now this is the new radius, so draw the arc. So this will start and it will join. So you'll get the puppet radius here. Clear? This is the last step, right? Okay. Guys, maybe I think your slides I give it to you in the form of PDF file, which will not help. So what I do, I will upload the PPT file, so it will be easier for you to understand this. Okay, I will do it today. So I will upload the PPT files. That will be a lot easier. Okay. Now to draw a line tangent to a circle at a point on a circle. Now you know what is a tangent, right? So tangent is a line that passes through the uh, you know the outer here, and then when you draw it, this will make a 90-degree to the center point, a perpendicular line. So that is the tangent. So now you have to draw the line tangent to a circle at a point on the so first the circle is given, mark a point C, and then let's see what's happening here. Next. So now you use the tri-square and draw the uh, this is how we made the tangent in the previous case also. You remember that? In the previous case, how we did this? See? Similar. How to draw the tangent. Once you have the arc, then use the tri-square and move it and we draw it. Very similar. Now we are using the circle. Initially it was an arc, now it's a circle. That's the only difference. So now just move it all the way, and this is the tangent, which is through the lines at the center C, and this line is parallel to this C. At the same time, it will make 90-degree to the center. That's what a tangent means. So if you draw this, connect this line, and this will make 90-degree. That is a tangent. Now this is the tangent. Okay. And now to draw a line tangent to a circle from a point outside the circle. The first one is on the circle. Next one is outside the circle, which is going to be very easy. Now you see there at the C point by using this, and then just move it all the way and draw this point here, and then connect these two by using a scale or even by using a tri-square. It will be a lot easier. I repeat again. I repeat. First things, we draw a line tangent to a circle at a point on the circle. On the circle means anywhere, here or here. It's on the circle. So how we did that? First we mark the this is the C, a point on the circle. Then now by using the tri-square, first join these two and then just slide it all the way such that the triangle will be parallel to this point on the line, and now you join it. This is the tangent at C on the circle. The next one is a point away from the circle or outside the circle, a point C, by using a similar method. Then you just slide it all the way and join these two. This is a 90-degree. Then from there, you join these two, and that is the tangent. Any questions? Let's see any questions there from our people here. Okay, Doctor, I sent you email. Please check it if you can. Why? What's the problem? You can send me message here. Should you want me to go to the email and check yours now? What's your problem? Are you sending me a secret message? Huh? Just whatever you discuss now. Is that very urgent or what? I sent you an email. Is it is related to the class or something? What? Say something. We are in the class. You know what that? There are 33 people in this class, and you want me to answer your email? Okay. Sorry about that. If you want me to check your email later, I will check it. If it's urgent, just let me know now. If not, otherwise it's okay. Right. So, okay. The next point here, guys, please answer. You have any problem about? Just let me know. What's your problem? Who's this guy? Are you here? You're not answering me. Do you mind to answer me at least yes or no, please? Guys, are you hearing me? Can you hear me or what? All of you hear me? Are you in this class? Yeah. What's this problem with this guy? Okay. All right. This boy has a problem, but he is not sending me any message, and he asked me to check his email. Okay, fine. Let's go back to our discussion now. Okay. All right. So the next one is when the circle tangent to other circle. Okay, that means this is very important, especially in the gearbox. I'm sure most of you who wants to become a mechanical engineers in the future, you know the gears, even the cycle, the bicycle, a simple gear mechanism, and also in your car gears gearbox, this particular uh, tangent is very important. Okay, so for the gear designers, gearbox designers, this is a very important thing. So that's why you should be able to understand why a tangent is required, how to draw the tangent. Please remember, you are not going to do this in your entire life as an engineer, because we have very good softwares, powerful softwares. We do that, but this you need to know. As an engineer, you should know the fundamentals. So later, when you use the computer, it's going to be very easy. Do I make myself clear? Don't complain to me, doctor. Why am I a secondary school student? Why you're asking me to draw circle, tangent? Oh my God, we already hate it. I know. I also hate it when I was in school. But now, when you are becoming an engineer, you should know what is happening. When somebody said as a gear design, you should know, okay, this is a tangential. So why we draw a tangent? Because the gears always transfer the tangential forces. Later you will know. Okay. All right. So that's the theory behind. Anyway, now we can continue. Now we are trying to draw the circles tangent to each other. Okay. So this is the tangent point. See, from the center to center, you find the tangent and join it, and that's the point is the tangent point. Okay, the center of the two circles and tangent point lie in the same straight line. I repeat, the center of the two circles C1 and C2 and the tangent point lie on the same straight line. That is the theory. Okay, maybe the R1 is the radius of one circle, R2 is another big circle, and the center C1 and C2 must be joined through the point, the tangent point. Okay, that's the idea. Now we see how we are going to do it. Draw it. Okay, to draw a circle tangent to the two circles, the first step is to draw the two circles C1, C2, and you just connect it by using the other C here. So how we do it? So you know this is a cam, especially it is very powerful, not powerful, very popular in the cars. All our car engine, if you open the car engine, on the top of the engine you will see this rocker arm. This is the rocker cam. Can you see how they do this? This is what we're trying to make this one here and this one. This one here. It's a difficult exercise, so I might give it to do it at home. Okay, because this might take 2 days, 1 or 2 days. Okay, but you should know how to do it. This is our actually our aim to draw the cams. All you know about cams, camshaft. You can check it in the internet. What is camshaft? When you open your engine, your car engine, when you see the car engine in front of your car, today I don't know whether we can make it or not. This is your car engine approximately, and in front of the car you will find the fan. The fan is connected by the belt. Remember that? You must have seen this. So when you see at the side, these cams are provided at the top. You can check it up next time when you open your car. Some cars, most of the cars, they enclosed it, but in the big engines, it's open. So this camshaft is continuously opening, and this will there's a rocker arm here, and this rocker arm keep on pushing the valves inside the engine so that the valve can open and close such that the engine will keep on running. So it's an extremely important mechanical component that you should know how to make it. Our job is how these arcs are made in a cam, because cam designers are very important people in the industry. If you go, you will know cam design is a very difficult job. I was a cam designer for an year or so, 2 years I was, and it was a horrible period, very very horrible. I designed a cam like this, so this cam will move and it will slide something, so it will run and it will do some work. Later you will learn. Right now we just try to understand how to draw the arcs, because as you see, the cams are made up of arcs. So these are the slide will slide on the arc and to do some work. All right, how to do this? So to draw a circle tangent to circle, so two circles and the radius of the third circle is r. Okay, two circles and the radius of the third circle equals to r. So first this r1, r2, and then r1, r plus r1 you draw, because the radius r is the radius of the third circle. Third circle is going to be there. It is given, and you draw first r1 and r2. Then take the r1 plus the given radius r, which is going to be the third circle here, and make another arc here. Very similarly here, r2 plus r, and make another arc here, which will join at this point. And you remember that last time we made the by using the tri-square, we make the similar. I think the similar method you can use it. So the new point is C here. That's the center of the arc. Then you can join it CC1 as the tangent, and then another one here to start the starting point and ending point. Take C as the center, any one of this as the radius. You can draw. If you finish it, it's going to be a circle actually. Okay, this is a circle. So if you see the previous case, see, this is what we are doing now. If you finish it, this will be, so it's a pretty easy case. See, you have to draw the this one. So you know this radius, and this radius is given capital R, so R plus R1. So you make the arc here, and similarly here another arc, so which are made at this point, right? And then join it here and here, and take this as the center and just draw it. It's very easy, correct? I repeat again, listen carefully, pay attention. This is also going to be one of the exercise, not today, but maybe this could be your homework. You can start, but if you cannot finish it, you can submit it later. So The radius r will be given is given. So you know r1, you know r2 as well. So all will be given. So first, by using r1, draw the c1 and c2. Okay, not the complete circle, maybe, but just half of the circle or quarter of the circle. Once it is done, the next job is to draw the this radius of this. So that radius is already given. So r plus r1, and then you make an arc like this. Okay, so that is the next point. Draw this, and very similarly, r plus r2 will meet at a point here. That is the center, and then you have to draw the tangent now by using a scale or by using a tri-square. No problem. And then the third step is easier. Just draw it, and that's why you got it. Somebody is asking me questions. Let's see what is his question is. What is his doubt? Doctor, we didn't do the last homework very good because there was a problem with the recording. It stopped in the middle of the class. Okay, all right. Don't worry. I'm not going to reduce any of your marks. Okay, so that's why this time today you start working in the class itself, and if you make mistakes in the previous one, maybe you can resubmit it again. Maybe I'll give you a chance. I was very upset when I saw your answers from the you know in the blackboard. Those did fine, don't worry. But if you are not satisfied with your previous work, do it and submit it again. Let me see. Okay, I know. But please don't always rely on the recordings. You have to pay attention during the class. I could see many of you leaving the class. Just you keep your system open and you go away. I don't know where you go. Maybe you go to the kitchen and eat some chicken. That's not the case. Please, whenever you are in the class, please be in the class. Pay attention. You can ask me questions, right? Many I can see when I saw your answers, you were just you were not in the class. If you were in the class, you would not have done that mistakes. So many silly mistakes. Clearly, it means you were not in the class. You were not listening. That I could easily make out from what you have seen. So, doctor, we need to keep all our work for the portfolio last later, right? Yes, absolutely. That is portfolio. We have to keep all the records, but don't worry. Once you submit the to the blackboard, it is there. I could access it anytime. But anyway, you have to keep a record such that if you have any doubt in the future, you could ask me, doctor. I did this. I got marks like this, and there is some issues. Then you can show it to me. So you always keep the record with you. Okay, keep a record. Good. All right. How can we know our marks if the last homework? Yeah, I was very upset yesterday. I checked 3 or 4, and I was very upset. And I thought, okay, if I correct it, you'll all get most of you get 0. So I will do it maybe today, and before 1 or 2 days, I will give you the marks. Okay. No, many did very well. Not really. No, some did very well. Of course, there are good students in this class. I can see that. Very good students also there. But the mistakes I've seen is so silly mistakes. I found very awkward how you made that such mistakes. You made us somebody did the freehand sketch, freehand arcs. How can you do that? I said very clearly, don't use it's not a freehand sketch, and you draw the arc freehand. Huh? No problem, no problem. I'm not here to punish you. Please try to understand. I'm an engineer. I'm trying to help you guys. I'm trying to train you. It's not my intention to reduce your marks. Please, unless you make silly mistakes, unless you're not sincere. What I need is discipline and sincerity. That's it. Engineering is a discipline. Please, we are not experts. We are not Isaac Newtons. We are not Alexander Graham Bells. No, we are not. We are simple engineers. We are trained for something, and that's what we are doing properly, procedure wise, systematically, and we are disciplined people. Engineering is a discipline, so I expect discipline from you. That's it. Attend all the classes, Submit all the assignments. A plus is nothing. You can get easily. All right. Okay. All right. Now you have a break. Go for a break, and let me continue our discussion because maybe I will give you another homework maybe after maybe 7 o'clock once we finish it. Okay. So you come back at 6:10. Have a break. We'll meet later. Thank you. 6:10 exactly. To chapter 6, I think. So all these chapters now you can download it and you use your laptop and watch it carefully because it's going to be like easy to understand rather than the PDF file. Do you understand what I'm saying? Don't worry, you won't get zero. Don't worry, don't worry. Just stop worrying now. Concentrate on the present work. Okay, you are wasting my time, please. All right, guys, let's go back to our discussion. Don't worry, I will never give you zero. Okay, unless you make some silly mistakes. No, not. Don't worry. I repeat, I am going to help you guys. Be disciplined, be regular. That's it. Okay, let's see. You'll be all right. You will be all right. All right, so let's continue. Uh, See, this is what we have done just now. We make the two circles, and once radius is given, we draw another arc which joins at point C. Then you draw the tangent to the center and then mark that cutting on the circle. Another point, starting point and finishing point. Take center C, the other one as radius and join it, and that's how you make the radius. And you can draw the circle tangent to the two circles. That's how you can make it. Now the second exercise is you have to draw an inner circle. Okay, the previous cases circles are outside. Now it's going to be inner. You know why? Because we are trying to draw this cam. So you know how many arcs are there. So we need to know how to draw such arcs. Okay, that's the idea. So the first step we have already finished. So the second one is just see the center of the two circles or tangent point. This we already know, R1 and R2. Let's see. Okay, the center of the two circles and the tangent point must lie on the same straight line. That is the theory, right? So C1, C2, and the tangent it all should lie on the straight line. Previous case we make R1 plus R if it is outside. This time it is R2 minus R1 if it is inside. This is R2 and this is R1. So R2 minus R1 is the key here. Just remember that. Okay, how to do this? First draw the two circles C1 and C2 with radius R1, R2. Then how you're going to do this? Now you see. And this point is what we are trying to make. So C1, C2 is done, R1 with R2, and then R1 minus R because R is already given. R is given. In the previous case, we put R1 plus R, this time R1 minus R. Draw the arc, and from R2 minus R, then the procedure is the same C here. Join C and C1 and C to C2, and then arc it, and now you have to join these two from here to there. Take C as the center and R is a radius which will join from here to here. You understand? Quite little complex, by the way. Let me repeat. Let me repeat again. Listen carefully. So this I'm not going to ask you to draw it now because it's little. So you have to use it. You have to do it at home. Maybe I'll give 2 days, like you did last time. But already I provided the PowerPoint for the slides in the Blackboard. Download it, the Chapter 2 PowerPoint. Run it in your laptop. Try to understand. Keep your laptop side by side, and then you start drawing it. Do you understand? Otherwise, it's going to be very difficult. Download the PowerPoint. Keep the PowerPoint near to your table, watching it, and then you start drawing it. Otherwise, you will be losing marks. Careful. So let's continue. Let's repeat this how we did this. So this is the first one when the tangent is outside. Now that's the first method. The second is now we are trying to draw something like this. Okay. Initially it was like here. Now it is out. So how to do that? Because if you draw this radius, these two circles coming inside the circle, right? In the previous case, it is outside. See, so this is outside. That's why you add it. But now this is going to be inside. You understand? So that's why we have, once R is given, this is going to be like this. Clear? This is what we are going to do. So where we are using it? Here you are using in the cam. The camshaft, we are using it. This we have already done it just now. This outside, this inner one. So these are very useful in the engine design. So you're not going to waste it, this knowledge. All those mechanical engineers and automobile engineers, the cam design is extremely important. And this is how they make the cams. Guys, you have any questions? I'm sure you must be worried now, huh? Any questions, please do let me know. Okay, let's go. So first, how we draw R is given, and then C1, C2, R1 and R2 also given. So R minus R1, then R minus R2, joining at C, then draw the tangent. Tangent is the points of tangent and the center will be at the same. That is the theory. So it should cut it at the top here, and then similarly here. Now take C as the center and R as radius. You can join it. Okay, understood? Any questions? It's very easy. The only difference is this circles, the two circles are within the big circle, so that's why you have to only remember the subtraction from R to R1, R to R2. Okay, then this will make a tangent outside, and these two circles will be inside of that arc. The third method is two circles and the radius of the third circle. So we are going to use the third part here. Now we are following the same idea, combining these two and join the first tangent, cut it there. Then the second will be from here to here, here to join it. Join these two Then take C as the radius which will connect, make a tangent like this. Okay, I repeat again. The idea is we are trying to draw this cam. All right. So for this cam, there are several arcs. This arc is connecting the these two circles, and this one is another one connecting like this, and this one is something like this. The other one is like this. So you have to identify how to draw this. This one we already found how to draw this one, and the second point is how to draw the tangent uh, for for the two circles inside another circle. This is what we have just now we have seen. These two, and then take C as the radius, C as the center, and R as the radius. So you can make this one. This is the this point, this one. We have just learned this part. This part we already learned from the first exercise. Clear? Some question is asked. Let me see. The third one is to draw the inner one, and joining the tangent of the two circles, the third method. Okay. So this is useful for this way, here and here. Okay. So when you draw this cam, you have to identify what is this radius. Is it from the outside? This is an outbound. This is like this, and this one is like this, and this will be like this. So if you want to draw the cam shaft or the cam, this is how you have to make. Let me see what question is being asked. Okay, what is this? Doctor, there is something. Okay, okay. You're going fast. Doctor, can you give us 10 minutes to pray? Doctor, slow. Okay, what is the size of the circle? I'm not giving you any size of the circle now. We are just learning how to draw. In the exercise, I will give the size. Do you understand? Okay, then can you give us 10 minutes to pray? Just now you went for. Huh? Okay, right. Okay. Okay, let's continue. Now let me repeat again because since this guy is asked. Okay, let's do it again because yeah, he's complaining that I'm going a little faster. No, it's not because I repeated several times. I don't know this guy. Are you? Maybe some people are finding the English is a little difficult. So that's why, for those who finding it hard to understand, I already uploaded the same PowerPoint in the Blackboard. Go download from the course description, run it yourself in your own laptop, watch it carefully because it's step by step it is given. Only the radius is not given. So in the exercise, I'm going to give you the radius, C1, C2, and all. Then you can draw. But all you need to know is the method how to draw it. You understand? Okay, I repeat again now. C1, C2, we have done this. How we did this? First, remember that this point. and this point are the tangents, right? So, and then take the radius from the center. So you have to draw this, and from the center you have to take the radius. This is what we have done. I hope you understand. Yeah, see, this is what we are doing it. And in order to do the, so this part is what we are trying to draw now. Okay. So C1 is this. I think this is C1 here. So this is C2. This is C1, and you're going to draw this radius R. This will be given. Okay. And this we have already done. You remember that last time we did this in the previous first case. This we did this. So this is already done. Next, this is done. Okay. This also we have already done. Do you follow me? Hmm. Okay, two circles on the radius of the third circle are, I repeat, uh, R1, R2, then radius will be given, R1 will be given. So you subtract R minus R1, you mark the arc here, and you know R and R2, take the other point, and that now you draw the tangent by joining C and C1. You know why? Because a tangent must join the center to the tangent point. So that is the theory. So that's why we're joining it here. Very similarly here also. In this case, you have to put these together. It's all come in the same line. That is what a definition of a tangent. So make the tangent point here. Similarly, join C, C2, and that will cut at the larger section here. Now take C as center or as the radius, which will join these two. Okay. All right. Then the third method is to another one. Here we are making a bigger circle and other circle. Some these two tangents we are trying to draw, which could be equivalent to in this case probably this one maybe. Okay, just check it. Okay, now R1, R2 will be given. R is also will be given in your assignment. Don't worry. So now you know R, you know R1, R2. So R minus R1, you take the arc here, and similarly R plus R2, because one point is away, one point is inner. So that's why we are combining these two together, and then take C as the center, and then mark the first tangent which joins C and C1, and similarly C and C2 will connect it at the tangent here. See, the point is tangent can be anywhere. So if you want to draw, the point here is the center and the tangent must be in the same line. So that way you can join it anywhere, any tangents here, this tangent to this tangent. All right. If you want for both cases, maybe you have to draw one more tangent here and another tangent here, and you can make another way like this. This is also a tangent. This is also tangent. The tangent is something. This is a tangent. It's all a tangent. Anywhere you can draw. Do you understand what I'm saying here? These all are tangents. So by using this theory, we are trying to, design the cams. That's why tangent to tangent, you have to join it. So you have to identify tangents, several methods. Now join this. So now you see here, the tangent to this C1 and C2 are set at the same position. So you can simply join it by taking this as the center, and from here you can make an arc. So in that case, the difference is when you make R minus R1, this circle is inside the arc. R plus R2, this tangent is outside the circle. That's why we are combining it to 2. Do you understand what I'm saying? R minus R1 is for those the radius R and the circle is within the tangent. R plus, if you put it is away out of the circle. So when you take this radius here, when you draw the radius, this C circle is within this radius, whereas this circle is outside the radius. That's why here you're adding it, here you're subtracting it. Do you understand what I'm saying? Correct? See, here, this is the tangent definition. Now, the first one is outside. This is very easy. Okay, and this is what here. Okay, this one and this one actually. This we already draw it. How to draw? We know that. Then we are trying to draw this one. But when you see this radius, these two circles are within the radius. So now you are using the plus here. Okay. So the first one is, since the tangent is outside, so we're adding it. So that is done. Next one is inner, inside. So from the tangent point, the circle is inside, so that you are using a negative R2 minus R1. We did this. Now you see within that circle, this radius, these two circles are inside. So that's why you are subtracting it. R is given R minus R1, R minus R2. So take that C as center, draw the tangent, and then similarly you join here, and then take C as center, R as radius, and now you see this radius, within the radius these two circles are inside. The next one is inside, one is outside. This is in, that's out. So for this you negative, here it is positive. Okay. All right. Any questions now before we go for the ellipse? Let me see how many of you are asking questions here. Okay, pray time. Yeah, you have pray time. Okay, okay. Go for prayer, and come back within 10 minutes. Okay. I think I at the last break I should not have. Anyway, go for a break and come back. So I will give you the exercise. You can start working on it. Please go now. So I'm gonna uh, show you one video so that everybody will see it again, and then we'll directly go to the exercise. Okay, because it seems most of you do not have an idea of how to draw it, because it's better if when we do it directly I can show you, but online it could be a little difficult. So anyway, that's fine. So let me show you a multimedia file, what we have been discussing, so it will give you an idea. Okay, so just pay attention, and then it'll be a little easier for you guys. Before we go for the one, but we discussed the elliptical one, the ellipse, the last one. When you see there, let me see the major minor. This is very simple. Once you, what we are doing it now is very a little complex. Okay, so let me show you a little small media file so that everyone can understand how to. Okay. So I can share it my. Let me see where is my file. So listen carefully now. This actually it gives you an idea how to draw the tangents, inner and outer, of the circle. Uh, Direction. Tangency, yes. So please listen carefully. And today, I don't think so. Okay, just
For this next one, we're going to look at these two circles.
so this
Which
is what
are
we've been
these two
discussing
circles
now.
here?
Just listen carefully.
And we're going to join them with, again, two curves which just create tangent points here and just create tangent points here. Same with the bottom. It looks a little bit like a small pulley wheel and a big pulley wheel with a belt going in between. The radius of this bottom curve, you can't see it very well on here, but it's 75 millimeters. The radius of the small, slightly less deep belt on the top is 40 millimeters. So what do I know about these two circles? Well, the only thing that I know about them are the radius is 15 on this one, and on this one the radius is 25. The other key point I know is where the centres are. The centres are fixed. On here it tells me, again, it's very difficult to see on the camera, but it's 60 millimeters between these centres, and they're horizontal. So how does that help me? Well, I've got a fixed point here and a fixed point here, which is this one and this one. If I deal with this little belt at the top, first of all, that's got a radius of 40. Now the curve comes round and just touches this circle here with a radius of 40. That means that the centre of the bigger circle that's going round there must be 40 millimeters away from here. 40 millimeters up here somewhere. Now I know the radius from the edge of this circle to that centre is 15. So if I add the two of them together, I'll get a total of 55. So I know that the centre I'm looking for up here is going to be 40 plus 15 away from its centre point. So what I can do is set my compass to 55. And I'm going to do that now. Be really careful with this because even the slightest little error can make a difference. So it's set to 55. Put the centre of my compass here. That's a fixed point. And I'm just going to draw a bit of an arc. Now somewhere along that line, somewhere along that arc, the centre point of my compass is going to be placed in order to draw the curve which is coming round and joining these two circles here. But I don't know whereabouts it is. I know the radius I'm going to set it to. I know the radius is going to be 40. But I don't know where I'm going to place the compass point. In order to find that, I'm going to look at this circle. And I'm going to use the same thinking on this one. This curve is coming round and it's just touching the edge of the circle and it's going off into the distance somewhere. Same way that this was. So that bigger circle there, which we can't see, has got a centre point up here somewhere. The centre point is going to be 40 away from the edge of this circle, up in this direction somewhere. So it's going to be 40 up there somewhere. But I don't know whereabouts it is. But I do know the centre of this one. It's 25 from there to there. And if I add on the 40, it makes a total of 65. So as before, I'm going to set my compass. Be really careful, set it to 65 this time, because it's 25 plus 40. Put my compass point in that fixed point that I know about and draw another arc. Now where those two cross over is where I'm going to put the pencil or the point of my compass in order to draw this top tangent point. I have to remember to set my compass now to 40. So go back, reset my compass once again, really carefully to 40 millimeters, and then I'm going to put my compass point on here, and trying not to get my hands in the way too much, I'm going to draw my curve there. Now, somewhere along here I've got a point, and somewhere on there I've got a tangent point. How do I find?
Guys, I hope now you can have a clear idea. Is that clear, everyone? How he made the tangent? So, what he was saying, like, this is 15, but the radius is 40 from there. So, from the center it should be 40 plus 15 somewhere. So he first make the arc, and he doesn't know where exactly it is because the point should be a common point that will make 40, that will join these two circles. So the other curve must be from this center, it should be 40 plus this 25. So then he made an arc here, put this as center point, and that will make the tangent here. Okay, listen, this is going to be the exercise for you. Probably I will ask the same for you, slightly changing the radius, and you can do it on yourself. You understand? So watch it carefully. It's very simple.
Behind them is take a straight edge and align up that fixed centre and align up where I put my compass point. Draw a line between the two of them. That then gives me
Tangent.
TP.
Tangent point.
I do the same going the other way. So I take my straight edge, I line up where I put my compass point, and I line up the centre of the fixed circle. Draw a line between them. That gives me TP. So what I did with this one is I took away, I added on the small diameters here, or the small radii here, and then I added them to the radius that had been given for the tangent curve. So in this case, that point there is 65 away from the compass point, and this one is 55. I'm now going to do the bottom. It's a similar way of thinking, but you just have to think about it in a different way. Once again, here are my two fixed points. And I know that this curve here is going to have a point where the compass is going to go up here somewhere. This point here on this curve is 75 away from the centre where the compass goes. This point around here is 75 away from the point where the compass goes. But I don't know exactly where to put my compass. But I can use these fixed points again. This point is 25 millimeters closer. This point is 15 millimeters closer. I know that radius is 75. So for this one here, I'm going to take off 15 because I know this point is 60 away from the area that I'm looking for. So I set my compass to 60. 60 even. Really carefully set it to 60. Put the point in that known position there, and I draw another arc. I'm ignoring these ones now. These were for the previous curve. This is a new one. This point here is 25 millimeters closer than the outside edge. So again, my radius is 75. Take away 25, leaves 50. Set my compass once again, really carefully. 50 millimeters. Put the point in this known position and draw an arc. There is where my compass point is going to go. I reset my compass to 75 because that's the radius of that curve. 75 millimeters. And again, without trying to cover over the drawing too much, I'm going to put my compass point there, and the compass is slipped. Put the compass point there and draw my arc. Somewhere along here I've got a tangent point, and somewhere along here I've got a tangent point. What I have to do is use my straight edge again, line up this centre with that centre, that'll give me a tangent point for here, then line up this centre with that centre, that'll give me the tangent point there. So there's tangent point, and lining up the centres, tangent point there. So I've now got a picture the same as this one here. Now, your task is to look at this, which is these two circles here, and this time we're going to use a combination of taking away a radius and adding on a radius, because this one goes that way and then it goes to the outside. So you're going to use the skills that you just learned on the previous example and you're going to apply them to solving this one here.
Okay, so now I hope you understand, some of you at least, whatever your doubt you have. Any questions now? Uh, Send us the link. Clear now, because I barely can see the drawings. You check yourself. I cannot spoon feed you. Okay? Who is this guy? All right. So sometimes you have to spoon feed. Why don't you? Can't you check in the internet? You don't check the YouTube, and that's how we have shown it now. Anyway, so guys, please take your minute after now, and we'll give you the link also. Because, yeah, I know. I'll send the link if possible. Let me see the link. This is one of the link. Let me check the link and I will send it to you later. Now, everyone, now we have 1 more hour. So, what you have to do, you don't need to submit immediately after this class. I will give you some more time. So, tonight I will send you one more, what do you call it, an assignment, but that you can start it now and you can submit it as it is, as together. Okay. So, what we have discussed this today, today's class. Before we finish it, let's see the last slide as well. So the point here is he was mentioning very clearly, so that you know somewhere where this radius, and that radius you have to find out whether it is within the circle or away from the circle. If it's away from the circle, you have to add it. Within the circle, you have to subtract it. That's the only difference. By the way, I will give you the what do you call it, the link also, so that you can check the YouTube as well. Maybe I understand it's a problem. Okay, so the last uh, slide here is to draw an ellipse. You know what is an ellipse, right? So ellipse is what do you call it? You just start a circle whose diameter is not uh, equal. If the diameter is throughout the same, then that is called a circle. Ellipse has two different, uh, radius. What is asking? Again, somebody is asking something. Doctor, I have a class at 8:30. Make it 48 hours for the assignment. Yeah, of course, I will make it 48 hours. Don't worry. I will never ask you to finish it within 1 hour. Of course, it's very difficult. Don't worry. Don't worry. Yeah, I know. Today you cannot, so I will give you 48 hours. Don't worry. But you have to start now. Then you can finish it for 48 hours. Don't worry. Okay. And the proper question will be sent through the link immediately, so you can upload it from the assignment. Okay. So anyway, you can start the work now, and you can submit it together. All right. Okay. So I think it's clear now. Let's see. So the ellipse, it's not going to be an exercise, by the way. So I'm not going to ask you to draw the ellipse, but definitely the cam is very important. The tangent, you have to draw at least like what I have shown you now. Maybe that one tangent with two or a couple of circles, you may have to do that. Okay, that's very important. It's not going to be asked in the exam, by the way. Don't worry. In the midterm exam, the cam and all may not be. We will see. Okay, so don't worry. These are exercises. The geometric construction is just an exercise, assignment only. Okay, so now for an ellipse, the smaller and the big diameter, there are two diameters that will be given. So the major and minor axis, we call it. Okay, there's the major axis and minor axis for an ellipse. Okay. Now I'll show you what is it. This is what just now. So for an ellipse, you have a major axis on the x and axis on the y. These two will be given in order for you to draw the ellipse. So major axis and minor axis. If you can easily draw the major axis with the center, and then very similar way you have to draw. Uh, I will show you because this again is very difficult for you to understand this how they use it, and simply by connecting the tangents. Okay, right. Okay, this is this maybe we can see it in the next class because I need to show you one more video, otherwise it's very difficult for you to understand. Okay. All right. So the ellipse we will see it in the next class. So right now you take all your minute afters because there's a lot of steps involved. I will let you know later. Right now, better you start this exercise now. The first exercise now, what you have to do is uh, this one. Okay, one. This one you have to do, and this one two. All right. So these two radius, you start better doing it. I will give you the radius now so that you can draw. So everybody be ready. Please keep your minute after ready and start drawing your margins first. Let's see. And the assignment will be sent tonight. So you add this, whatever you're doing in the class, and add it together and send to me as the third assignment. Okay? Yeah? All right. So the tangent point to draw an arc on the given radius. Now you start doing the first, this one. So the radius, you can take the radius as the radius is equal to 20 millimeters. Okay, so you can start doing it now. If the radius is 20 millimeters, you know how you can do that. First, what you have to do is draw a line, free line, and another line perpendicular. This is not perpendicular. My electronic pen is giving me a lot of trouble. Okay, so let me try it here itself. So first draw this line and take the radius 20 mm. So from there you make the square for 20 mm and find out the center point. All right, and take 20 this as the center, 20 as the radius. Cut it here and then join it and extend this line, and this is your radius 20 mm. Is that clear? Do it now. This is your first exercise. Take radius as 20 mm and draw this radius first. The second one is what you're going to do is this one. So here you draw the two lines. So first do that. Let me give you the, like I said here, take 45, and then here this radius is, let's say, 15 mm. Here also 15 mm. Then you can draw the, find out the line 1 and 2 and draw this radius. Okay. So this is the second exercise. You have to start it right now, and you submit it through the assignment along with the tangent, other tangent exercise. You submit it within 48 hours. Okay. Right now, I want you to start these two so that if you have any questions, you can ask me. Do it now, please. Okay. Yes. Any questions? Yeah, he's asking questions now. Can you repeat the first one? I will show you the first one. 20 mm 2 centimeters. Yes. 20 mm in 2 centimeters. Yes. Yes. Okay. The first exercise. Start doing it now. This is your first exercise. Please go on now. And once you finish it, let's do the second one. Okay. Can you see my desktop? Yeah. Okay. so many questions. Huh? What are the sizes of the two straight line? Why you bother about two straight line? Just dot two straight line and mark it 20. That's it. Okay, the blue lines can be of any length. Right? Right? Yeah. This can be any length. We don't care. This can be of any length. But the radius is 20 mm, so just make the radius and then join it simply, extend it. That's it. You know why we are doing this? You have any idea? Because of this. Because of this, we are making this radius. You understand? So that's why we are doing this. We are making this radius here. Okay? Yes. Hope you understand that. Correct? All clear? Guys, keep this, keep it. You have to send it to me along with the second assignment, the third assignment. Nothing is going to be wasted. This is an exercise. You have to submit to me. So keep it record. How to send it? Yes, tonight I'm going to send the actual assignment. Then along with the assignment, you have to send it. Clear? Okay. How many of you finished it? Still people are doing it? Can we go to the second exercise? Come on, answer me. Well, how many of you have not finished yet? Only some smart 3 or 4 finished. The rest, there are 20, 32, 33 people here in this, 32 people here in this class. Only 3 has finished. Remaining 30. What about you people? See, you can send to me after 48 hours, of course. This is part of the assignment. So, grades will be given for this as well. Can we go for the second exercise or still no one answer? Take your time, guys. I know. Take your time. Take your time. I will give you another maybe 5 minutes, another 5 minutes I'm going to give you. Okay, so let's move on to the next exercise. Now we are drawing an arc tangent to an inclined line. So it is given as 45 degree. So you can draw any lines, any length, lines of any length, but the angle should be 45. And then take radius equals to 15 mm. So I write here radius is equals to 15 millimeters, not centimeters. And then what you have to do, so this is the exercise that you have to do it now, which has to be accompanied with your assignment 3 when you submit it. So what you have to do, so like what we did here. Now first thing what you do, you take two lines. First mark a point and draw not vertical lines, any angle, but the angle is given as 45 degree. So first you make this 45-degree angle with two green lines. Not necessarily be like that. You can draw a horizontal line as well. You understand what I'm saying? You can draw horizontal as well. But the angle must be 45. Then use your tri-square, mark a point, draw the arc, and then you draw the tangent. Similarly, for the other one at 45 degree, you make the radius 15 mm is given by using the tri-square at the point C. So take C as the center and to mark the tangent point, and you join it, tangent point 1 and tangent point 2. Then by taking C as the center, 15 mm, you draw the arc. Okay, please go on. This is your second exercise you have to submit to the blackboard. You are on now. You can start. You can start now. Guys, you can hear me, right? Somebody said no sound. I'm sure you have sound. Do the parallel line has to be the same length, not necessarily be. It's just the arc is very important, as I mentioned earlier. The two blue lines of any length, but the angle between them is 45. That is given. Okay, let me repeat. Yes, yes. Okay, let's repeat since he is asking. So first you draw, let's say, vertical or horizontal doesn't matter. Okay, so what you do first? Let's take a point. All right, and then you go using your protractor, draw two lines. make sure that this will be 45 because that is given, right? So this line can be of any length, no problem. Then take this point, some point here, and the radius is given as 15 millimeters. So take the radius, and then use your protractor and draw this parallel line, the tangent line basically as here. Okay. Similarly, take the radius. This is R, and very similar here also. Take another one, and using your tri-square, it there. This is the center point. And now what you do, you have to draw the tangent line, tangent point by using the tri-space again as shown here and another one here. So take this as center. This radius, you can draw the radius and then you can extend it as you wish for some length. That's it. But this is most important. Okay? Right. So let's see how you can do that. Radius R is given, and then you draw the tangent by making the arc. Draw the line. I'm sure this is what you want to do. Okay. So what you did, keep the 3060 on parallel to this, then move it all the way, and then join it there. Similarly, repeat the same. Is it here? And move it on and connect it there. That point is a center point. Now we have to do the next tangent point 1 and 2 in a similar method, and draw this. That is the tangent point 1. Try this first. TP1 and TP2 if you draw, then your problem is solved. Clear? If you have trouble, please download the Chapter 2 PowerPoint in your laptop. And this entire this PowerPoint is available. You can run it on yourself. And no problem. You still have time. You have 48 hours. Tonight from 11:30 to tomorrow and after tomorrow 11:30, you have 2 days to submit the assignment. I'm going to send you two more exercises on the tangent. So you add these two with that. Totally, you send me 4 drawings within these 2 days. Is that clear? Now start doing it now. If you have any problem, do let me know now. How many of you finished until now? Doctor, this one is the homework. Yeah, this all are homework only. Do the parallel lines has to be the same. Would you be repeated? Yes, doctor, this is a home. Yeah, it's a homework. Yeah, you finish it. That's very good. So wait for the assignment to be. What's your name? What's your name? What's your number? Can you who finished this? Send me your number. Let me check. You're such a good guy. You finished it. Huh? Just send me the number, please. Okay, 204019. Very good. Good. I will mark your number. All right. So the rest, give it a try. And this is an assignment. You remember that. So once you finish these two drawings, keep it as it is because these two exercises will be added in the assignment. So since you have already done it, there will be two more like we have seen the CAM. So those two exercises you add it and combine it together and submit it by 2 days now. And for those who found you think yourself your previous assignment is not good, maybe you can try again. Yeah, four in total. Yes, four in total. Yes. So if you feel that last time the guy who was making the drawings freehand, you made such a big mistake. So you do it again, add this together, and send to me. No, submit to the blackboard. Doctor, can you? But it all, it, but it all the four in the homework. Yeah, yeah. Two already you have done now. Two only remaining. So when the in the assignment there will be four questions, but the two questions you already answered now in the class, and two more only you have to do. So you add the two and combine it together and submit it as an assignment 3. Is that all? Is that okay? Hope it's be okay. Any more questions, please? Anybody? Any questions about your? So what I'm going to ask, we can put it in one paper. Yeah, right. You can put it in one paper and the A3 sheet. And if you wish, you can take each drawing separately and submit separate also because I'm giving you 4 attempts. So 4 attempts means you can submit 4 different uh, these drawings separate. That you write your name and number. That is the most important thing. Or if you send the whole in an A3 sheet and submit me as one file, it's also good, no problem. Got my point? All right. So uh, now I'm going to show you what I'm going to ask you. Okay. I'm going to ask you. This is your homework. Okay. Just watch it. Can you see it, right? Yeah, you can see it. So these two we have done just now, right? To draw an arc of radius r tangential to the arms of right angle. This is what we have done just now. And this two is also, the second also we have done just now. This is 45. So this is what we have done just now. Okay. This is not necessary. And maybe this is your exercise that this is your homework. Okay. So the x or this everything will be given. So we have to draw uh, the this one as an exercise. Okay. One and the one. I think which one is very difficult. I think this is difficult. So okay, I think that will be good. Um, this one and this one. So only two are remaining. So these two will be given. Only two exercises. Two already are finished. That will be sent to your. You will receive an email, and then you have to finish it within 48 hours. Okay. Any questions? You know now your question as well. It's very easy, right? Both are on the outside, so you can mark it from here. And this x minus r, here also x minus r. Then you have to repeat it here and the other side also. Okay. It's fine. One is x plus r, and one is x minus r. We should draw the lines outside. We should draw the lines outside. What do you mean by draw the lines outside? I don't understand. We should draw the lines outside. What do you mean? I will send you the link of the YouTube video. Then you can do it easily, okay? I'll send you the link for the YouTube. Uh, Now, please, all of you, just follow the link. You will find it. So this is the YouTube link. Now, how many hours about the first homework? The first homework, I don't know what you mean. How many hours? What do you mean by hours? I don't understand. What do you mean by hours? How many heroes? How many hours? Or how many hours? The first homework, not first homework. For today's work, I'm going to give you 48 hours. Don't worry, 2 days. Okay. So today and tomorrow. So you have to submit it by day after tomorrow night 11:30. All right. Okay. Any more questions? So wait for the assignment to be given to you tonight, and then you can start your work right away. So that's all for today and today's class. Hope you guys. I know today is a little tedious, but that is how I told you. Engineering job is a very difficult job, so be prepared. Okay, for the next 4 years, you have to work very hard, and of course, we have the privilege of being an engineer. We create everything. We run this world, so be proud of it, and try to learn, and take it in a good spirit, and don't worry about your grades. Just be disciplined and be regular. You'll be all right. Thank you very much for all of you for your attention. We'll meet on next week, same time. Until then, a good night and goodbye. Yeah, yeah. You want to say something, please? The rest you can go. Those who want, you can leave this. If somebody's asking questions, you can still. The others you can go. Any questions? The class is over, so go take rest. Thank you very much. Bye.